Today we are going to go backwards. We're going to be given the roots, and then we are going to find the polynomial equation that those roots came from. So I'm going to tell you 5 is a double root, which means 5 happened twice. And 2 and negative 3 are roots. I'm going to share with you that there are 2 methods in order that you can do this. And I'll show you why you would choose method 2 after a little bit. Okay, so method 1. If 5 is a root, that means it had to have come from the factor x minus 5, because if you set x minus 5 equal to 0, you get 5. If 5 is a double root, well, you're going to have that factor twice, because double means it happened twice. If 2 is a root, it came from x minus 2. And if negative 3 is a root, it comes from x plus 3. So we are going to FOIL this out. And I'm going to take 2 at a time. So on the left, when I FOIL that out, I would get x squared minus 5x, and minus 5x is a minus 10x in the middle, plus 25. If I FOIL out the right, I get x squared plus 3x minus 2x is a plus x minus 6. And then you're going to have to multiply those out again. And how you do that is you take the x squared times each of those. So x to the 4th plus x to the 3rd minus 6x squared. And then you take the negative 10x times each term. So negative 10x to the 3rd minus 10x squared plus 60x. And then you're going to take the 25 times each of those. So plus 25x squared plus 25x minus 150. And then combine the like terms. So you end up with x to the 4th, x to the 3rd minus 10x to the 3rd is negative 9x to the 3rd. Negative 6x squared minus 10x squared plus 25x squared would be 9x squared. 60x plus 25x is 80x, and then minus 150. That's the polynomial that those 4 roots come from. If you wanted to check that, you could go to a graphing calculator and put that polynomial in and make sure that it crosses the x-axis at those 4 places. But what I really want to show you is that we do have another method you can do that. You pair up the numbers, so 5 and 5 and 2 and negative 3. Find the sum of those 2 roots. 5 plus 5 is 10. And then find the product is 25 when you multiply them. When you have that, your quadratic that it comes from is always going to be x squared minus the sum. So it's the opposite of the sum times x plus the product, so plus 25, which, as you see, is the first quadratic we have over to the left. Doing the same with the 2 and negative 3, the sum is 2 plus negative 3, negative 1, and the product, 2 times negative 3, is negative 6. So writing our quadratic, we know it's going to be x squared minus the sum. So the minus a negative 1 would be plus 1x. And then the product stays the same. And notice that's what the polynomial was on the left. And then you would FOIL it like we did down below. The reason you would want to choose the second method is if you have imaginary roots. For instance, if I gave you find the equation that has the roots 6, 3 plus 2i, and 3 minus 2i. Again, write them out. 6, 3 plus 2i, and 3 minus 2i. These two would be very ugly polynomials to write out. X minus 3 plus 2i and x minus 3 minus 2i would be very ugly to FOIL out. So that is why we would want to choose method 2. Okay, method 2, you find the sum and product of those two roots. The sum is when you add them, 3 plus 2i plus 3 minus 2i. So 3 plus 3 is 6, 2i minus 2i is nothing. Product, you multiply them, 3 plus 2i times 3 minus 2i. So you get 9 minus 6i plus 6i, subtract out, minus 4i squared, which is really a negative 4 times a negative 1, so plus 4, which is 13. So using the rule, x squared minus the sum of the roots times x plus the product of the roots, you would get x squared minus 6 times x plus 13. That is the quadratic that 3 plus 2i and 3 minus 2i come from. And then in front of it, we've got to take care of that 6. Well, 6 comes from x minus 6. And then you would multiply those two polynomials together. Take x times each term, x to the third minus 6x squared plus 13x, and take negative 6 times each term. Negative 6x squared plus 36x minus 78. And so your final answer, your polynomial that they came from, is x to the third minus 12x squared plus 49x minus 78. If you were to check that one on a graphing calculator, since the only real root is 6, it should only cross the x-axis at positive 6. But that is why you would want to know method 2, is because you don't really want to multiply out the quantity x minus 3 plus 2i times x minus the quantity 3 minus 2i. You would rather just do this sum and product and get that quadratic.